everyone, we welcome you to KCHEF where we share knowledge and enrich education. I am Adwitiya Anant and currently I am pursuing my B.Tech in EEE from VIT Vellore, and I'll be your chemistry faculty and we'll be dealing each and every topic of chemistry in details, and will make sure that at the end of each lecture you are left with no doubts.
Hi everyone, this is the fifth and the last part of the video for the playlist of matter in our surroundings. Just make sure that you have watched all 4 parts of the video which have been uploaded before, and then come back here because here we have the topic Let Us Be Friends with our Ncert. Now, why friends? Cause this is the last part and we need to check how much we have grabbed from all the 4 videos, and here we can take an analysis of how much we remember. Here you have the answers to all those 9 questions at the back of the Ncert, the questions which are given at the back of your Ncert book. So moving on with the first question. The first question says convert the following temperatures to the Celsius scale. Now when you convert from Kelvin to Celsius, you have to remember that you only need to subtract 273 from the given value. So similarly, when 293 Kelvin is converted into degrees Celsius, you have subtracted 273 from here and 20 degrees Celsius is the answer. Moving on to the B part, 470 Kelvin is equal to 470 minus 273, which is equal to 197 degrees Celsius. Just remember this point, Kelvin to Celsius is minus 273. Second question is just the reverse of the first question. You have to convert Celsius to Kelvin. And here you have to reverse the process again, plus 273. Remember any one of them and then you can solve the question. No need to remember both the tricks, that from Celsius to Kelvin add, from Kelvin to Celsius subtract. Remember any one of it. So when you convert 25 degrees Celsius into Kelvin, you just add 273 and you get the answer as 298 kelvins. Similarly, 373 degrees Celsius is equal to 373 plus 273, which is equals to 646 Kelvin into Kelvin is equal to is missing over here. Fine. Moving on to the third question of your Ncert. Why I have highlighted the question is that because it is first of all a give reason question, and the chances of coming such type of questions in a short answer or maybe long answer, like they can combine 2 of the questions and give in long answer, is very much. Like out of 100%, more than 75% of the chances are of you getting a give reason question in your examination. So we have 2 questions in Ncert. A says, naphthalene balls disappear with time without leaving any solid. What can be the reason? We know we have studied sublimation. So the reason is because naphthalene ball sublime directly changes into vapor without leaving any solid. That's why it disappears with time without leaving any solid. The second question is, we can get the smell of perfume sitting several meters away. If you have watched the video part 2, there we have referred about scent bottles or something similar kind of questions we have discussed there. So the answer to it is because perfume contains certain volatile solvent and diffusion is taking place here and diffuse faster and can reach people sitting several meters away. You write these 2 points and you get full marks. Moving on to the fourth question. The fourth question demands to arrange the following substances in increasing order of force of attraction between the particles. The force of attraction between the particles is also called as intermolecular force of attraction. This is just a short notation. It is not scientific notation. I didn't write the whole thing. It's intermolecular force of attraction. But remember not to use such terms in examination. Please use full form. So you have to arrange water, sugar and oxygen in increasing order of intermolecular force of attraction. So oxygen is a gas, okay, water is a liquid, and sugar is solid. We have compared the intermolecular force of attraction in video part 2. Yes, video part 2, there was one table given. So if you refer to that table, if you have notes, here you can answer it very easily. Intermolecular force of attraction is the maximum in solid, least in gas, and medium in liquid. So increasing order of intermolecular force of attraction will be gas, liquid and solid. That means oxygen, water and sugar. Moving on to the fifth question. Here it is. They're asking, what is the physical state of water at 25 degrees Celsius, 0 degrees Celsius and 10 degrees Celsius? 10 degrees Celsius, you know, is the boiling point for water, and 0 degree is the melting point where we get ice, and here we get vapors. So answer is very simple. At 25 degrees Celsius, it's liquid. At 0 degrees Celsius, it can be liquid or solid, because from here it starts getting converted into ice. Not whole liquid is converted into ice, so it can be a solid or liquid. Remember this point. And 100 degrees Celsius can be a liquid and gas, because here the change of state of matter is happening at this point. Hence, the water can be present in both these states. Above 100 degrees Celsius, it's definitely gas, and below 100, it's liquid. But at 100, it's liquid and gas. Very important question again. This is confusing. Moving on to the sixth question. The sixth question says, give 2 reasons to justify. Again, I have highlighted this question as it is a give reason question, and you can expect such questions in short answers for sure. So the question demands the answer for water at room temperature is liquid, because its freezing point is 0 degrees Celsius and boiling point is 100 degrees Celsius. So water remains in liquid state between 0 to 100 degrees Celsius. That's why water at room temperature, which is around 25 degrees Celsius, we dealt it in the previous question only, is liquid. Second question says, an iron almirah is a solid at room temperature, because melting point of iron is higher than room temperature. Therefore, it remains in solid and it doesn't melt into liquid. Very simple. You can get a similar type of questions where you need to answer the question thinking into the mind the terminologies. Video 3 again. We have dealt each and every topic in details in our various videos. You just go and watch and come back. Moving on to the seventh question. The seventh question is, why is ice at 273 Kelvin? What is 273 Kelvin? When you change into Celsius, from Kelvin to Celsius, you have to subtract 273 Kelvin. 273. So 273 Kelvin minus 273 is equal to 0. That means 273 Kelvin is 0 degrees. Okay? Okay? 0 degrees Celsius. So why is ice at 273 Kelvin more effective in cooling than water at the same temperature? Ice at 273 Kelvin will absorb heat energy or latent heat from the medium to overcome the fusion to become water. Hence, the cooling effect of ice is more than water at the same temperature, because water does not absorb this extra heat from the medium. We have studied the latent heat of vaporization, right? So similarly here, latent heat, when state changes happen, no, like when solid changes to liquid and liquid changes to gas or vice versa, there is one extra term, latent heat, at the point of change of state. So of course it will cause more cooling effect. So moving on to the eighth question. The eighth question says, what produces more severe bumps, boiling water or steam? See, steam at 100 degrees Celsius will produce more severe bumps, definitely. Why? Because again that latent heat term comes when we deal with steam. Because extra heat is hidden, it is called latent heat, where the boiling water does not have this hidden heat and hence it can produce more severe bumps. Okay, whenever you have to answer any question related to the point at which the state of change of matter is happening, remember the hidden answer is latent heat. You write latent heat, which is the keyword, and you score full marks. So that's it for the video. We have our final task where you need to specify A, B, C, D and E. We have dealt similar question in part 3 of the video. If you have any doubts, then go and see the part 3 of the video and come and answer it again. Here one more revision point is when you increase the temperature, solid changes to gas. See, increase heat and decrease pressure, and temperature and pressure are vice versa when they are related in terms of change of state of matter. Like when you increase temperature, pressure will decrease and solid will change into gas. Similarly, when you decrease temperature, pressure will increase and gas will change into solid, or gas will change into liquid. So try answering this question in the comment section. Coming on to the doubts. If you have any doubt, like any doubt, even a simple one, please write it in the comment section. We are here for you and we'll try to answer it within 24 hours of our time. And please, it's a request to all of you to watch all the 5 videos which are related to this topic, matter in our surroundings. I am very sure once you study all these, you don't need to study from anywhere. We have compiled each and everything for you. Thank you everyone. That's it for today. We'll be moving on to a new chapter on a new day soon. And yes, we are here for you talking about live sessions. We'll be arranging one very soon. The day is not too far. That's it for today. Stay connected and stay tuned for more such videos. Please like, share and subscribe our channel and help us and grow with us. Thank you.